Okay, thank you all for being here. I'm really excited that we have Nishadh Kalladath joining us today for our Pangeo Showcase presentation. Nishadh is a NORCAP expert in data science and machine learning at the IGAD Climate Prediction and Applications Center, ICPAC, in Nairobi, Kenya. He is actively involved in research and development of impact-based forecasting systems for the East African region. Nishadh holds a PhD in environmental sciences from Bharathiar University in Tamil Nadu, India. Currently, Nishadh is working on a UN CRAF'D-funded project with the Disaster Risk Management Program at ICPAC, aiming to operationalize impact-based forecasting through hazard and impact modeling using the storylines approach and leveraging Bayesian networks. First learned about Nishad's research at EGU last year and thought it was really amazing, and I'm so honored to have you here. Please, Nishadh, go ahead with your presentation.
Uh, Thank you, Max, for the invitation and for the kind introduction. So I will share. I will make the my screen into in presentation mode. So we will discuss about Ensemble weather forecast, data streaming with Kerchunk and VirtualiZarr. Our presentation agenda is we will be looking into background and method overview, then go into the GEFS and ECMWF workflow, then discuss about the applications, then we will discuss about the way forward, where we will emphasize the issue of the challenges with the Zarr version 2 and version 3. I would like to highlight the project team members behind the work. We have two projects. It's ongoing at ICPAC. First one is on SEVA project, which is on strengthening early warning system for anticipatory action. And another one is complex risk analytics funded project called E4DRR. So it is the work which we are going to be discussed is started with the SEVA project during 2023, where we can use this ensemble forecast system, apply the SIGAN model over that forecast as a post-processing method, the cost effectiveness and doing it very fast was the objective. Then going into the E4DRR project, which is started very recently, 2024. It is majorly focusing on how we can use this ensemble forecast system for risk assessment and impact-based forecasting. So with this, we can check into how this ensemble prediction system works. It is in a normal weather forecasting method, but within a slightly different initial condition of the atmosphere to see a range of possible outcomes. So this possible outcome is very important or essential for the decision making because it gives the probability which can be used to compare it with the historical observations, extreme values, and use it as a kind of a thresholds. And with the thresholds, you can monitor the forecast and use that as a risk assessment tool. So the issue is that it generates massive data volumes. For example, each 6-hour cycle forecast model run cycle, daily it is 4 times. ECMWF produces from its IFS model, it's around 250 GB per cycle. Because it produces for 85 time steps, and each GRIB file is around 5 to 6 GB in size. And in the case of GEFS, it is 30 ensemble members, and each ensemble member is made it into a separate file and comes around 48 GB in total. So to make that kind of vision where we can use this ensemble prediction system as a risk assessment tool, to do it for a regular monitoring daily or sub-daily monitoring, it needs a kind of analysis ready or data streaming method. So this is where we started to explore majorly on the discussions in Pangeo community, and the methods like Kerchunk, where we tried to explore. Uh, so if you are checking it with the current methodology, where we have libraries wgrib 2 or the Python-based popular library Herbie, it would be a repeatedly downloading and decoding the forecast files are involved, and it is in a heavy bandwidth, and we might end up in need of storing the data set. So this is the current methodology we have in hand. But if you want to move into a kind of data streaming where these solutions Kerchunk and VirtualiZarr comes into place, where the Kerchunk transforms the large binary archive into a lightweight JSON or paraquet reference maps, and allowing X-ray to open remote data sets without basically downloading them in a sense. And in the case of VirtualiZarr, it is extending the Kerchunk into many chunked objects across cloud stores into unified analysis-ready Zarr datasets, like in local data, like an integration with IceChunk. So the GRIB index Kerchunk, the methodology actually starts with a earlier Pangeo showcase, which is made by David Stube during March 2024, where it indicated about that this amazing method of integrating the GRIB references and sampling the GRIB references and using the index files, which is a simple text file, to get the reference informations and make a fully compatible reference file with all the time steps involved in that. So that was our major awareness about these methodologies. And so before that, we were doing within a scan group of the entire FMRC. For example, in the case of GEFS, we would be scan grip using the CF grip. So this is the backend of Kerchunk methodology, where we need to scan grip the 2400 files and make the reference in JSON files and use it for the extreme value analysis or the empirical probability analysis we were discussing. So this methodology where David Stube showed, we worked more on that methodology, and we finally end up in a three-stage methodology. But in the case of which comprised of one stage 0, where we will be pre-build reference map structure as in a template. So we will be running the scan grip and make a 2400 file one time for a single FMRC or single time step or single Zulu. Like every day it will be 4 times, so we will be doing it for one time and make that as a template. But the second three stage of starting from stage 1 to 3, it is to run this methodology for everyday usage or everyday analysis, where we will use a new data structure to ensure the template validity, so that we can compare it with the old or the pre-built reference template, and then use the index file to identify the byte positions and combine these two, stage 1 and stage 2 methodology, 2 outcome into a final reference map, which can be a paraquet file. This is a major advantage from the earlier Kerchunk scan gribbing the entire 2400 files. So instead of 2400 files, we need to only scan maybe a sample of one or two files. One or two actual GRIB binary files, and other remaining file you can use the IDX or the index files. With this, the methodology is developed, and we have a discussions on how we are approaching this methodology in the Kerchunk discussion number 530 and 572, and especially on GEFS we have the video record of the demonstration of how this GFS can be data streamed with this method of GRIB index Kerchunk and sampling the GRIB binary and using the index files. So if you could check the this GitHub link, you could find a README explaining about this methodology and how this pre-processing and a final test comparison between the dynamical Zarr GFS is carried out. And in the discussion in Kerchunk, there is a good comparison on this dynamical Zarr. So the dynamical Zarr is a GFS data store available in source scope. Which mirrors the GFS GRIB into an Zarr formatted dataset. So this test compare dynamical Zarr GFS, actually compare it between the dynamical Zarr and the reference file created from this GRIB index Kerchunk. And there is a comparison of the plots for extreme value analysis. Then there is an ECMWF workflow, which I just updated, where it is the same methodology of GFS is followed, and we are developing the final step of integrating the stage 2 and stage 3. But we could identify some issues, but it is overall in a final stage to make another discussion in Kerchunk as well, which shows the entire workflow. So these are the two demonstrations I would like to show, but I will keep it as a presentation only form. Maybe we can continue the discussion, or maybe you can try it from your side. I would be having an issue majorly is that there is a one-time expensive pre-processing we done on ScanGrib on all the 85 files for ECMWF or 2400 files for the GFS. It is in a private cloud storage. Maybe I would put that reference. It's a paraquat file. Put it as a downloadable zip format for two demonstration purposes. And yeah, so with this, we will go to the next step, how this methodology is being applied in our different project and how it can be extended further. So the first application is that you can faster processing of the hazard information. You can actually do a risk assessment in near real time. You can data stream or identify the extreme value exceedance, threshold value exceedance, and make some kind of this kind of maps in the corner where we are identifying this method as a kind of a data streaming where we can compare it between the situation of DVD or CD era and YouTube or Netflix era, and it gives hopefully it is easy to communicate how this method is differing from that kind of downloading routine where you need to download the entire GRIB file, or even if you are subsetting using a wgrib2, there is a need of you would be downloading the entire global data set where you cannot do it for a latitude longitude subsetting is not available. So this is one application, and another one application is that we can do the multi-variable access, or by doing this references, we are actually potentially doing the referencing of the entire GRIB binary store or the messages, and you can identify certain variables you want. For example, in the case of Seva project, we are applying a CGAN deep learning model on a GEFS or ECMWF forecast, the raw forecast for post-processing methodologies, and it triggers 10 to 15 different variables per forecast. And downloading this 15 variables and all the ensemble members is a major bottleneck. Using this method, we can do that in a very fast manner, and we don't need to store or worry about the storing of this dataset for experiment and other development of the model, because you can do it whenever you need the dataset. And this is actually a kind of a win-win solution, as the others of VirtualiZarr envisaged, where we can maintain the current status quo, where the global forecast producer and open data repository like the AWS open data registry can maintain their existing workflow or the existing dataset, while the end users or the users like us only need a thin, lightweight reference layer over that. Maybe if you are going for an iChunk or VirtualiZarr, maybe an iChunk store, virtual store would be working as a kind of thin, lightweight reference system above the GRIB or AWS S3 data bucket. So which gives a multi-year data access as well, so that because the one-time reference creation, it can be reused by multiple users. So far we discussed about the background of GRIB index Kerchunk and the applications. Now the difficult part comes, and it is actually a enlightening moment with my recent participation in Zarr Summit 2025. I couldn't catch up most of the codec and other things, because I was almost a end user of the product Zarr and the other libraries. And the discussion actually enlightened this kind of realization. So what we identify from all this method is that especially we tried the method of converting or avoiding the issue with Zarr version 3. So the issue only rise is on FS map or the part of FSS spec if you are using it with Zarr 3. So the workaround we used is a kind of CF grid, reading the paracute using a op store for S3 chunks, and then CF grid with temporary files to download or kind of identify the chunk we need and make it into a data stream into our local system. So this is entirely, there is no Zarr codec is being used. So this is one of important realization we came to know that while all this coding and doing it with LLMs. This is a major challenge. We could get some workaround, like another major issue if you are going with this non-Zarr codec is that the performance is a major bottleneck. We could identify that if you are using a Zarr version 2 in GEFS, the plot, the 24-hour exceedance plot for next 10 days, it takes only 2 minutes. But if you are doing it with this the Zarr 3 or the CF grid non-Zarr methodology, goes around 30 minutes. So there is a major performance degradation is there if you are not with the current method what we are using. And the way forward is that there is an HRR parser where this VirtualiZarr library, Max and collaborators are working. So the way forward, we are seeing that it is to develop in a very similar parser following the HRR parsers currently using VirtualiZarr and Gribberish for GRIB decoding. So this is what the presentation all about. I'm pausing my presentation here and